All right, so today we're going over 3.3 and it's called It All Adds Up. Okay, and our focus today is going to be adding and subtracting polynomials algebraically and graphically. And how are polynomials like whole numbers, and how is adding and subtracting whole numbers like adding and subtracting polynomials, and how are they different? Okay, whenever we're thinking about algebra and working with variables, it's useful for us to consider how it relates to numbers, systems, and the operations on numbers. Okay, please listen. So one of my phrases that you will consistently hear me say in this unit and then for the rest of the school year is, if it works in number land, then it has to work in algebra land, or in integrated 3 land, or in polynomial land. Because the only reason why we have polynomials is because we understand the general truths that are true in number land. Okay, so let's see if we can make some useful comparisons between whole numbers and polynomials. So your brain, I need it to say, how are these the same? How are these different? Okay, let's start by looking at the structure of numbers and polynomials. Consider the number, and the way we write numbers is really a shortcut, because 132 is really 100 plus 30 plus 2. Okay, and you guys are like, seriously, Miss Johnson? This is like back in 2nd grade. Exactly. So I need you to pull back into 2nd grade. So it says compare 132 to the polynomial x squared plus 3x plus 2. How are they alike and how are they different? So I peeked at you guys and you all had some pretty good things to say. They both have variables and exponents. No, 132 does not have any exponents. So no on that one. So go fix that. Not a big deal. They are like, it says they are alike by being in order. This is really huge. They each have different amount of x's, and one doesn't have an x. Two has only, and 3 only has 1. So what they're saying here is, if you look at 100 plus 30 plus 2, you see it's a composition. It's a sum of something. This is a sum of something. This is a sum of something. And then this person talked about the order. So that's actually a really good sentence. Someone else said one more thing that I wanted to share. Let's see. Yeah, they're alike because there are multiple variables which make up a polynomial. 132 is 100 plus 30 plus 2, though they are also different because of how they are written, not just, but they're not equal. Very good. So if I had to rewrite 100, I could say this is 100. This is 1x squared. This is 3 10s, and this is 3 x's. And this is 2 1s, and this is 2 1s. So that's how they're the same. So they wanted you to write an analogous polynomial to this. Let me see if you guys did that. Let's see. 2x cubed plus 6x squared plus 7x not equals to 5. I think you mistyped right there. I think it's supposed to be a plus 5. So whoever this is, good job. I think you just mistyped. It's this answer right here. So if you don't have that written down, you should be writing it down right now. I know it's kind of hard to go back and forth between Zoom screen and your screen, but just do your best. So let me actually snip this so that you guys can all see this at some point. Where is mine? There you are. Copy that. Oh, it's not such as the background. All right, so someone asked in the chat, hey, how did you get that, Miss Johnson? What do you see that's the same here, guys? Let me make it smaller. I wish I could make it small enough that like the numbers would sit right on top of each other. So someone asked, how did they get this? So can someone else help? Where did they get 2x cubed plus 6x squared plus 7x plus 5? Where did they get this? Person who did this, how did you get it? Yeah, it's from the number 2675, exactly. So I just started with 5, that's the 1 place, 7, that's the x place, 6, that's the x squared place, and 2, that's the x cubed place, right? So these are all just place values. Here, these are place values in base 10. This is 0, 10 to the 0, 10 to the first, 10 squared, 10 cubed. Right? And these are of the place value of x cubed, right? Okay, moving on. It says, when write an analogous addition problem for the two polynomials and the sum of their polynomials. So I'm really trying to draw these these two together. Do you guys all see how this is going to go? So then I'm going to move over here and I'm going to look for my friends who have added these together. I was hoping that someone would add it on top and on bottom, so you really, really saw it. Did anybody do that? No, no one did that. No one did it. So I'm going to write that. I'm going to make you write me it. I'm going to write it in here. I'm going to make you take my time. So how do I write 132 as a polynomial? I'm just pretending. How would you write an analogous polynomial for 132? You guys already have it. I just want you to say it out loud. Yeah, it's x squared, right? Plus 3x plus 2. Okay, I'm going to put this right underneath. I'm going to add these two. Now, write the second one. I'm going to put plus. And I'm hoping that these line up. If not, then I'm just going to scoot this guy over a little. Because I really want them to line up, because then that's the power. Can someone show me 451 as a polynomial? 451. Yeah, 4x squared. Oh, wait, why is this? Oh no, I'm not in the land of math. Sorry. 4x squared plus 5x plus 1. See how it's all lining up so pretty? You guys all see? I really want it to be pretty. Do you see how I'm taking my time making it pretty? Okay. Is equal to, now if I could draw a line here, I would, but I cannot. So I'm going to get over it right now. Okay. So then if I add those two together, what would I get? Go ahead and add those two together. I know the answer is right here, but really think in your head, can you add those two together? Go ahead and do that. Really truly do that. Don't just sit there and copy someone else. Like, this is you. This is if you want to do better on this. If you don't want to do better on this, then that's on you. Okay. I told you this is the month of November, when I'm like, this is hustle. This is like the last quarter for me. This is the last quarter. I am like hustling for all of you to make sure that you're going to end up with the grade that you want to end up with. Okay, so go ahead and get that done. I have a bunch of people with answers in the chat. See if they're right. Just because they put an answer in the chat doesn't mean they're right, right? Just because they put an answer in the chat. Yes, 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 most likely. Okay, so yeah, so I'm not going to look at this answer. I'm actually going to add these together. Okay, I'm actually going to add these together. Okay, so x squared plus 4x squared is 5x squared. 5x squared. Is that true? Is one of them plus 4 of them 5 of them? Yes. And it says 5. So far, my answer is looking pretty good. All right. 3x's plus 5x's is 8x's. Ms. Johnson, you're saying it funny. Yeah, because you forget how to add things. But if I say x's, it's almost like I'm saying 3 dogs plus 5 dogs makes 8 dogs. And then this turns into like a kindergarten problem, right? Just because I put an x here does not make this, like, remember how before in kindergarten you'd be like 3 apples. John had 3 apples. And mom gave him 5 more. Right? How many apples does John have now? And you'd be like 8 apples, right? It doesn't change because there's an x. So that's why I say it like that. All right. 2 plus 4, I've been knowing that since 6. So, uh-oh, did I type it wrong? I typed it wrong, my bad. I put a 1 here. I got too excited. So this is a 3. So 583. Thanks for catching my mistake. Man, when you guys catch my mistakes, that's a huge win for me. Thanks for paying attention and having my back. So 5x squared plus 8x plus 3. So Ms. Johnson, you haven't taught us anything new. Exactly. That's the value of you guys going through before we all go through together, right? So some of you are like, so I didn't learn anything new yet. You didn't learn anything new yet. Not yet. Okay, so here's where we're going to get into the new things. Okay. So we did this. I guess I'll clip that later and put it here. How does adding polynomials compare to adding whole numbers? You guys should all have a really good response now. Does this make sense? Any questions on this? Actually, I want to look at what you guys wrote there. let's see. What did you guys say? How is it the same? How is adding polynomials? We're basically adding all the numbers and exponents together, just like we're adding. I don't think you mean you're adding the exponents together, but I understand what you're saying. Just like we're adding whole numbers, adding numbers, well, the polynomials. Yes, these terms, x squared and 3x cannot be added because they're not like terms, right? I can't say, like, think about money in front of you, okay? I have a $100 bill and I have two $10 bills. Do I have $3 now? No, I have 100 and two tens. I have $120. Okay, very good. And polynomials, good. Very good. So all of these are great. Just be careful on your wording. Wording matters because how you say something is how you're understanding it. So be very particular when it comes to this. So I would say something along the lines of, because when you're adding numbers, you're paying attention to place value. I have to pay attention to like terms. In place value in polynomials, that would be x cubed, x squared with x squared, and so on. All right, this is none other than me putting it in a funky form. It says, so the first one says add h plus k. So what's h? It's this guy. What's k plus this guy? Look, they even lined it up for you. This should not be a problem now, right? This should no longer be a problem. So I will actually clip this super quick and make sure that you guys are all comfortable with this. So let's see, I'm gonna put this background. So h plus k looks like this, right? And they want to know what that value is. And so because I want to have more space, I'm going to put it over here. And then so add these together, see if you get the right answer. Add these together, see if you get the right answer. Okay, take a second, peek at what my friends have put over here. This one. Let's see. Yeah, that's pretty beautiful. Yeah. Whoever Sophie Germain is, you're perfect. Yes. Same with you, Evelyn. Yes, perfect. Okay. So a bunch of you got it perfect. X squared plus 2x minus 8. Why is that so, Miss Johnson? Because you're just adding like terms, right? As long as you have all the terms lined up, and that's what your teacher told you, right? Back in the, I don't know, maybe second grade, make sure your place values are all lined up, and maybe you use the paper that had the lines going up and down, or maybe your teacher had you turn your paper so that you can line up those place values really neatly, remember? So same thing goes here. You guys are all fine with this. Let me see, G plus F, yeah. Oh, look, they're trying to confuse you. Tell me really quick, looking at this right here, G plus F, if someone lined it up like this, what are they ignoring? What are they ignoring? If they lined it up like this. Yeah, they're ignoring like terms. That's the equivalent if you were adding these two together and you lined it up like this, that's the equivalent of going 1,345 and then it's plus 21. I'm just making plus 51, and you would add it like this, right? Let's say your teacher told you to add these two numbers and this is how you lined it up. Do you see how wrong this looks right here? Does everybody see, like, this looks wrong, Miss Johnson? That's how wrong it should look to you if you line them up this way. Does that make sense? So you got to push this, like scoot this over to wherever the 2x would line up with whoever. Does that make sense? Okay, so now let me just review. A, B, C, they all make sense, correct? You all should be, like, Ms. Johnson, you haven't taught us anything new. Exactly, I haven't taught you anything new yet. Okay, so but what about this this D business, Miss Johnson? L plus M, and the only thing you gave me was this graph plus this graph. Do you want me to put them on top of each other? Do you want me to put a big old plus sign? Line plus line equals a line? No. So ideally what you would want to do is, notice here it says L of X. So they're saying the Y value, I want you to add the Y value for L plus the Y value of M at each X. Does that make sense? What? Yeah. So let's take a second so we could do this together. Okay. The first number I'm going to go for is 0. Find the 0 when X is 0 here, and find your X is 0 here. Okay. So the very first one I'm going to do, just so that it makes sense to us, I'm going to find L of 0 and add it to M of 0. So that's this number here plus this number here. What's that number? 2. Good. What's that number? What's that number right there? You guys all see it? Oh, okay. And you want me to add those two together, Miss Johnson? Yeah. So you want me to add 2 plus 1? Yes. Okay. And then you want me to plot that point? Yeah. So let me get you a table because that's how Miss Johnson loves to organize everything. I'll go with 3, 4. I'll go with 4. So here's how my table is going to look. And you can create yourself a similar table. You don't even need a table. You could just make the points. So in this, I'm going to put X. In this one, I'm going to put L of X. In this one, I'm going to put M of X. These are coming out funny because, you know, they're capitalizing for some reason. Plus M of, you guys all see what I'm doing? Plus M of X. It's a little bigger, so that doesn't look fine. Okay, so you're saying, Ms. Johnson, when X is 1, L was 2, M was 1, so it's 3. Oh no, my numbers are messing up. Sorry, and I spoke wrong. It's 0. When X is 0, L was 2, M was 1, 3. Okay, one more time. X is 0, L was 2, 1, 3. Good. Then pick another number. Yeah, just ignore. You guys can skip slides 7 through 9 because I messed up on that. Okay, let's do another one. Let's do the number 1. Okay, so what is 1 for L? Like, look at your own because this is like squinty and I don't know. I don't want you to get squinty. I have 2 questions. Did you clean this up? Did you even attempt to clean 1 is 3. Very good. 1 is what over here? So this is 3. Yeah, this is 0. So you want me to add those two together again, Ms. Johnson? Yes, 3. Ms. Johnson, both of them are 3. This, I don't know. It could be a rule. It could be, I don't know. Let's just continue. Let's just choose another completely different number. Let's use 5. I don't know. I'm just choosing another number. 5. What is 5? 5 comma what for L? Yeah, 7. What about for M? What about for M? It's -4. I agree. Ms. Johnson, it looks like I found a pattern. Yeah, you found a pattern. Very good. So some of you now see the pattern. If you wanted to prove it, you can find the equation of this line, which you know how to do, slope-intercept form, y equals mx plus b, find the equation of this one, and then just add them together, okay? So when you get graphs like this, you don't have to think about, sometimes students get overwhelmed, like, oh my gosh, I don't know how to add a line plus a line. That's okay. Can you add a point plus a point? And you're like, yeah, I can do that. Yeah, 2 plus 1, you can do that, trust me. So now you know how to do E and F. And then I want you to see what patterns could be said. Okay. What I want you to work on next is, do you think subtraction is going to be different? Do you think subtraction is going to be any different than addition? And I want you to work on these here, the rest of the slides in our Desmos. I don't know where I'm going here. So just make sure that you are all like set. So there's only a couple more slides that you would have to do. Let me see. Let's see. Yeah, so the subtraction slides are here from 11 through 15. Please complete those to make sure that you guys are all good. Your exit ticket, I want you to do just the A part. For our Flipgrid for today, just do the A part. Stop this video.